All right, Q&A AOA today. We're in the module on functions, and in particular, we're working on composition of functions, which is actually learning target number 1, so very important to get that. Any question today? Happy to look at homework, or possibly there's a question about the course or about the test that we have in a week.
Is the test, like when it opens on next Friday, is it just you have to have it completed before midnight? Like you just do it throughout the day when you have time? Okay.
Right, exactly. Okay, so I just happened to see this thing, and we mentioned the test, and I'll mention that this is a lot of people miss this, even though they probably kind of know what's going on with it. And it's very simple. What those people are not getting is that you just have to support your answer. In my class, you almost never just give the question and the answer. So F composed with G of 1, okay? Someone will just, maybe do this mentally, thinking that, it's kind of like too easy to show work. But if it's easy for you, this is the learning target, okay? So just feel, blessed that it's easy for you, and show work as if it's a real problem, okay? So f of g of 1, you're going to say, okay, well, let's see, g of 1 is the x value. What is the y value when x is 1? Well, it's 2. And so what you have to do is you have to show the one intermediate step for a problem like this between the question and the answer. I've got to see that number 2 somewhere. Okay. So you got to say, okay, f of g of 1. G of 1, the inside there is 2. So this is the same thing as f of 2. And then f of 2 is 0. When x is 2, what's y? 0. So 0 is the answer. But if you go right to the 0 without showing work, you need to support your answer. We always support our answer with something. And I need to see that too somewhere in there. Any question today? Brianna, do you have any question?
No.
So by now we're learning the drill. To get to the right page in the ALA, we go for start in mom, as always. And in section 3.4, it says and in ALA. I might have pulled it out of section 3.4. Let's see. Oh, I put it before. Yeah, I pulled it out and put it before. So composition and decomposition. And we're going to follow this link right here. And the class code just populates, so you don't mess with that. But your name is 22222. 22222. That's your name. And put us all on the same page. Okay, so yeah. And Brianna, are you getting here, Brianna?
Yes, I just got in.
Okay, great. So yeah, composition, it's likely something that you have seen before. That one thing that throws a few people is that little circle notation right there. And they think it's multiplication, but what it means is composition. F little circle g of x is f composed with g of x, f of g of x. So the input is actually a function. The input of a function is a function. As usual, we'll try not to say too much, but let you learn by doing. And, I'm sure I'll chime in and have a lot to say, but we'll go ahead and get after it. And, we have just regular problems to work here on the first slide.
I have a quick question.
Yes, ma'am.
Are we supposed to complete like all of the questions, or if we don't get all of them done and we still like contribute and do as much as possible, do we still get the points for this assignment?
Yeah, if you're in the meeting and you contribute, you get credit.
Okay, thank you.
You're welcome. So I encourage you to talk. Hopefully more will be here because like we just said, the bar is kind of lower if you're in the meeting. Just contribute and contribute to the community here. And you're good on this ALA, but if you're not in the meeting, well, you might not understand the assignment, or you might not complete it, or you might just feel clueless about something and don't know what to do to show some struggle with it so that you would have be counted as having done a good faith effort on the entire ALA.
Could you help make sure I'm setting up that equation right? I've been kind of struggling with making sure that I was setting these up right to solve.
Okay, so I'm going to use Zoom tools here because they're a little bit nicer than the ClassKick tools. So this, of course, means f of g of 2, okay? And so really the first thing we want to do is figure out that number on the inside, because g of 2, we know that's just a number. We've done those before. So we're just going to figure out what number this is right here. And then whatever that is, we're going to run it through f. That help?
A little bit, yeah. I've just been kind of having trouble with like understanding these equations. Is it like possible to do like one of these together and then like go from there? If not, that's totally okay and I can like go for it, but I've just been kind of having trouble with these ones in particular.
Um, yes, I'm fine with that, unless Brianna, you know, you
Yeah,
have a problem with this.
I've been having trouble understanding these two.
Oh, okay, all right. So the G of two, let's just figure out what that is, and then we'll run the result through F, because composition of functions, um, in a picture, looks something like this. Let's do this. Hopefully I have a good function machine picture here. We kind of get the machine thing where if it's a function machine, for every input, there's exactly one output. Oh, not seeing the machine. Okay. Well, the machine thing is like this. So it's kind of like a conveyor belt, and you've got a machine here, and it's we can call it F, and there's a thing here, a number like two maybe, and two will go into the machine. That it's the input, right? So it's the X values that are the inputs. The machine does something with it and spits out exactly one thing. And the exactly one has to be true because it's that's the definition of function. Exactly one output. Now that number, it all depends on F. What is our function F? Um, Now in composition, there's another machine, and then the output of the first machine becomes let's call that first machine G, because that would make it like the problem we're doing. But the output of the first machine becomes the input for the second machine. So out comes another number. That number might be 1. And then 1, we're going to run it through F. And so F takes that 1, does something with it, and spits out exactly one number. And whatever number that is G composed with F. I'm sorry, F composed with G of 1. We know G of 1. We just watched down here that G of 1 is equal, or G of 2 is equal to 1. Okay, we just saw that happen in that first red machine. Output gets run through F. F does something with it, spits out exactly one number. And whatever number that is whatever this is here, that is F composed with this G of 1 or G of 2. F composed with G of 2, whatever that number is. Let's say that that number is 3. So on this problem, F composed with G of 2, and we have to figure that out. What is G of 2? G of 2, 3 times 2 minus 5, which is 6 minus 5, which is 1. So that's F of 1. And what does F do with an input like 1? Well, it squares it, doubles the result, and adds 1. 2 times the square of 1 plus 1, which is 2 times 1 plus 1, which is 2 plus 1, which is 3. So that's our answer. That's F composed with G of 2. Okay. Brianna, you good with that?
Yes.
So like here, you don't have a number for the input. Let's see. So in that case, all we can say is that it is X. So that's not going to be a number. That's not going to be a number. It's just X. And what does G do with X? Well, it makes it into, what was it, 2X, 3X minus 5. The other one was, so it takes an X, makes it into 3X minus 5. F does something with the 3X minus 5, and what it does with the 3X minus 5 is it squares it. It squares the 3x minus 5, doubles the result, and adds 1. And that's f composed with g of x. And that's all you can say. It's the answer. You can't get a number for the answer. It's just an expression in x. And you don't need to simplify it. In fact, I kind of like it better if you don't simplify it. I think, Hannah, you were asking about this, about simplifying. It's
Yeah,
you can,
I couldn't, sorry. I just couldn't tell if we were supposed to fully simplify or like if it was okay to leave some, because I was messing up on that on the homework.
yeah. When it comes to composition, nice. When it comes to composition, it's better not to simplify it for two reasons. One is the normal reason, which is to me, it's better evidence of mastery if you don't have a nice polished answer at the end, which you would certainly get if you were cheating. And secondly, it it helps with the domain problem. If you also are asked for the domain of the composition, it's a much easier problem if you deal with your expression in unsimplified form. So Brianna, you think it's going to be the same answer for C? Is G composed with F the same thing as F composed with G? Namely, 2 times the square of x, 3x minus 5 plus 1? Or will it be different, you think?
Um, the same.
Well, go ahead and work it out. And, we'll see. Everybody's artistic today, drawing the function machine. And yeah, you have to switch F and G. So Jackson, how's it going with D there?
I'm still working on it.
Did I do it wrong?
Okay, well, it's 2x squared plus 1. That's f of x, right? So you left out the plus 1. Okay, someone want to help Anna there?
Was I supposed to put an X instead of a -2 on the left side?
Yeah, it's basically, I mean, it kind of goes like, well, yeah, this is f of -2. F of -2 is a number. That number, whatever it is, will get run through f again. And notice how there's no um, 3 times something minus 5 in this problem E, because it's just f. There's no g there at all. So um, let's see. So let's figure out this f of -2. That's like the inside function. F of -2. Okay. What is f of -2? You take -2, you run it through your machine there, and what comes out?
Would it be -4x² plus 1?
Well, let's see. What we've done is take -2 and throw it right in there for x, right, Hannah? So -2 goes in there. And so that's why it's 2 times the square of -2 plus 1. That makes sense?
Yes, thank you.
Sure. And then, so what number is that?
Are you talking about the -2²?
Well, the whole thing.
Okay.
Jackson, I believe that is going to be the right answer, but in between, I think that's +1.
You're right. Sorry.
Okay, so Hannah, you probably remember PEMDAS, right?
Yes.
Okay, so that means you do your squaring first. So you're squaring -2. What's -2 times -2?
4.
4. Nine. Yep. Then we're going to take 9, run it back through F. Okay, so when we do that, it's going to be, we're going to take that 9, run that again through F. So that's going to be F of 9 now. So 2 times the square of 9 plus 1. Okay, you have to do the squaring before the multiplication, right? In PEMDAS, it's the exponent EM, then the exponent, then the multiplication, right? +1, right? Now I just I'm looking at slide 2 now, and I just gave a little sermonette on show work and show the intermediate step. But for these problems, you don't do that. Basically, you might do a check it's good to do a check on these decomposition problems. But you don't, basically, you don't show work, you just kind of investigate it, you just kind of inspect it. You inspect it, and then you come up with your answer. And then, if you have any doubt about it, you can check it. And but that's pretty much all you would do. Okay, so Jackson, you want to say that, okay, it's F composed with G. So yeah, so you want to say that G equals the
Oh.
X plus 3, right? Okay, sure. Let's see. Are you on, did you use 22222 for your name, Azucena?
And no.
Okay, so that's the first thing. So when you are in mom, you follow that link for the assignment. And you put for your name 22222. Okay.
Okay.
That'll get you here, and I'll put you on the first slide. Then you can use, in Class Kick, we've got a pen tool and a text tool that you can use to put your name on slide 1.
Okay.
Name and color. Okay, Hannah, your answer, well, before you put the squaring on there, it was technically, see, what you have right there is technically correct, but it's cheating, okay? Because if you let the outside function be just X, then you're always allowed to let the inside function G be the whole thing, and it works every time. So basically, you can just rewrite this for G. F of X is always just X, and it works. If you put this in for X, oh, you get this thing that you're supposed to get. So it is technically correct. It does work, but it's kind of like cheating because it's not really doing anything.
What's the other way that I should write it for like the test that's like the correct way?
Okay, so, well, the way you wrote it is fine. It's just you need to come up with a different G and a different F to, have a legit answer. So, what would be a way to do it, Jackson, for part B on slide 2? Okay, so now what we're going to do is check it. So to check it, we're going to say F of anything is 3 over that thing. Okay. That's her answer. So this is a check. So basically, I just wrote down her F, and then the input is going to be the X minus 7. Well, does that work? F of that thing is 3 over that thing. The thing is x minus 7. That's what we were supposed to get. So that is the correct answer. And so the answer then is her answer of g, the inside function is x minus 7 is f is 3 over x. And notice how quickly she just did it. She just recognized it. So it's like until you learn to recognize it, it's like, how does she do that? But with what this activity is intended to do is to drill on this so that you learn to recognize a correct inside function and a correct outside function that is considered a legit decomposition of the function. So we're going to circle this because this is a correct answer. Now, I'm using the language of inside function and outside function. In part C here, basically what you've done, Brianna, is write basically the whole thing for G, but that doesn't really, that's almost like never the right way to do it. And so we're going to let G be, okay, inside. What's inside? 2x plus 1. Okay. Notice G is inside. It's the inside function. Inside. What's inside here? 2x plus 1. What's outside? Well, outside, f of anything, f of x, it's the square rooting function. Right, Brianna? We're going to apply the square rooting function to the 2x plus 1. And so if that 2x plus 1 then becomes the input for the square rooting function, then we get square root 2x plus 1. Okay, so I'm doing the check now. And that's what we're supposed to get. Because that's what h is. That's what we're supposed to get. So that composition works. So now when we write that, it's like f, that doesn't look like a very good answer, right? F is a square root symbol. Well, in that case, we'll just call it x, square root of x. Square root of x. So that's our answer for C. Do you see how that works as an answer, Brianna?
Yeah, yes.
Okay, great. So Jackson, I think before you were in the meeting, I gave a little rant on these problems. And sometimes people don't get credit for mastery because they leave out this part. So that intermediate step has to be there, just the way you did it. right? Because we are defining X as number of items. Okay, Alyssa, do you know how to get where we are in class kick?
Um, no, I'm trying to do it on my computer because I'm on my iPad right now.
Yeah, you follow the link in Mom, right? This link?
Yes.
Okay. And then when you log in, when you go to the login page, your name is 22222. That's what you use for your name.
Okay.
Okay, I was just saying that looks, the answer is correct. Um, the intermediate step is a little, it's really just G of um, 1 over X. Because this is G of f of X. G of f of X. What is f of X? F of X is 1 over X. So the inside there is just 1 over X. And then we say, okay, let's run that 1 over X through G. What is G? G is the subtract 3 from the input function. Well, you subtract 3 from 1 over X, and that gets you that thing. Why does X have to be positive?
Because X can't be 0 because you can't divide by 0.
That is correct. Well, X actually could be 0 because
Yeah.
let's think of this. Do you see what I'm saying?
Hmm.
Let's find f of g of 0. It's actually not a problem because g of 0 is -3. And f of -3 is 1 over -3. So this 0 here is a perfectly good input for the composition. Now, what about negative values? Can negative numbers, can x be negative?
It can be negative, right?
Yes, it can. Right, we could run this whole thing with say negative, 1, and then we just end up with -1/4. So let's talk about domain. Here's a definition. The domain of f composed with g of x is the set. The domain is always a set, right? The set of inputs that are allowed. The set of all x in the domain of g. So we are concerned about the inside function. And so that's going to be important in part D there. The domain of f composed with g of x is the set of all x in the domain of g such that g of x is in the domain of f. Domain of f. Okay. So let's take this first part. The set of all x in the domain of g. What is the set of all x in the domain of g, Jackson?
I am not sure.
Okay, the set of all x in the domain of g for g of x here is the set of all real numbers. Any number can have 3 subtracted from it. So that's never a problem. Okay, so now all we have to worry about is that whatever number g of x turns out to be, that it's in the domain of f. Okay, so what numbers are allowed to be inputs for F. What is the big issue? Well, you can't divide by 0, right? So the big issue is we can't have a 0 denominator. We can't have x minus 3 equal to 0. So what can't x be? Well, x can't be 3, right? Add 3, add 3. You can't have x equal to 3. Can't have x equals 3. Well, I circle it like it's the answer. But it's very close to the answer, right? So then what is the domain, Jackson? If the only problem is we can't have x equal 3. That is absolutely correct. All real numbers except 3. The union of everything to the left of 3 and everything to the right of 3. So now G composed with F, we know that's 1 over x minus 3. What is the domain for that? What is the set of allowed x values, or the set of allowed inputs? Let's see, Alyssa, have you found us?
Yes.
Okay. Okay, well, if you look at this definition, we have to think about two things: the inside function G, and then kind of like the whole thing. Now, in C and D, the inside function is F. So what is the set of all x in the domain of the inside function? And we just saw that this was, 1 over x, and then subtract 3 from it afterward. The -3 came afterward. And that doesn't have any impact at all on the domain. Okay. So what is the domain of the inside function f? So now we're concerned about f. I shouldn't do that. If I may use this notation, domain of f. Domain of the reciprocal function, 1 over x. I was just saying, what is x not allowed to be?
If I'm not wrong, 0.
It's not allowed to be 0. So in words, we would say all reals except 0.
Mm-hmm.
Now, when it was all reals except 3, we wrote the domain like this. Now it's all reals except 0, so we can write the domain in a similar way. And we know that's going to be the domain of the composition also, because the -3 doesn't affect the domain. The -3 doesn't affect the set of inputs that are allowed. Is that an x squared? Oh, it's a minus. I got you. So on slide 8 and following, y'all can be dividing the labor and just taking individual problems. But actually, what you should do is also look at the other ones, because that'll help you with the rhythm that this activity is intended to produce. We're looking for an inside function and an outside function. And we're looking for Alyssa. Hello, Alyssa. Where are you?
Yes.
Where are you? Did you use the name 22222?
Yes, sir.
Okay. Did you sign in? You didn't sign in though. I can see that. On slide one.
Up there, let me see. On slide 1.
Yeah.
I actually have to start getting ready to go to work. Did you want me to finish the rest of this on my own? Like on the PDF or something?
I think it closes at 5:30.
Okay.
Okay, so Hannah, you're very close. course, we can always check it. So let's check it. You know, we think we are hoping we have an answer. We can always check it. So in this case, the check would look like, okay, outside function is f, so that's 1 over something. And if the inside function is x minus 2 to the 4th, well, what is that? That's 1 over x minus 2 to the 4th of 16, actually.
Should I have just put the parentheses for the g of
Yeah,
x?
exactly.
Okay.
Okay, so you want to do the check, as I say, on 41. If you do the check on that, on number 41, it just turns out to be, you put the x squared in for x, and you end up with 1 over x squared to the 4th, which actually is 1 over x to the 8th. Inside function and an outside function. We need to clean up number 41. And then we've got the nasty problem, number 43. Do you see why that doesn't work, as I say, on number 41 in slide 9?
Yeah. I'm trying to work it out on my notebook.
Would
Okay,
that be
so,
right for question 43, or do you have to actually solve it too?
well, you want to do the check. And so the check on your answer goes like this. Okay, f of anything is the cube of that thing minus 1. Well, what if the thing is x cubed plus 1? Okay, well, I don't think that's going to be the same thing as this, right? It's just a lot different than what we were aiming for, right? So, right, you can see that, right, Hannah? It's just a lot different.
Yeah, so to get that, how would I, and I think you said this was a hard question, but how would I solve it to get to what it's supposed to be?
Okay, so basically it's kind of like trial and error. And it's just a recognition thing. It's the kind of thing that, you could like look at it for 15 minutes and not be able to figure out, and then you go away and you come back and you see it. But maybe someone else can help out there and see what's going on with 43, because it is, traditionally in this activity, it's the nastiest problem of all of them. Even though the ones on slide 11 look scary, they're easier than number 43. So as I was saying, on 41, what's inside? I mean, the G is going to be the inside thing. What is the inside thing in that problem?
X minus 2.
Right, exactly. So G of X is X minus 2. Okay, so then how do we finish the problem?
Would it be 1 over x, the f of x?
Okay, well, if we had that, then what we would, if that were one, whoops, wanted to use a zoom tool there. If this were 1 over x, then f composed with g would be 1 over x minus 2, which is not quite the same thing as what we need.
Okay.
But actually, what f turns out to be is exactly what you had there before. So Alyssa, what you might do is go to slide 10 and try to identify, say in number 44 or 45 or 46, try to identify an inside function and then an outside function.
Okay. You said 44 through 46?
Yeah. So it looks like Jackson's got 44, so maybe you could do 45 or 46.
Okay.
Identify an inside function, just the way Jackson's doing on 44, and then an outside function. Perfect. Good. Alyssa, what's the inside? It's easiest to start there. What's the inside function?
2 plus x over 3. I mean, x to the third power.
It could be that. That's one thing about decomposition, is that there could be more than one correct answer. There could be more than one correct way to compose two functions to get h of x. Basically, what we're looking for is, for the inside function, just anything that's inside something else. Yeah. Yeah, that's better than what you said, Alyssa, because that's yeah. So that is definitely, what I would use for something that's inside something else. Now the something else, that's just the raise it to the sixth power function.
That would be h.
Well, the outside function is f.
Okay.
So h is what is given. So we don't need to produce that. We need to come up with an f for our answer. And the f is the outside function, which is the function which raises its input to the sixth power. So the function which raises its input to the sixth power, yeah, we just call it x to the sixth.
Expand.
I like that one, Jackson, on 48. You look at that, you're like, there's no way F and G are the same thing, but they are.
It threw me off for a minute.
Okay, the cat is destroying the house here. With 7 minutes left in the meeting. Number 47, Alyssa, what is something that's inside something else?
Would it be x minus 5 over x over 2?
That is what I would use. Yeah. Looks like you started to put the radical symbol on there.
Oh, yeah.
Okay, but it shouldn't be there, right? Because you put the radical symbol on there and you no longer have something that's inside something else. Because the radical is really the outside thing, isn't it?
Yeah. So it wouldn't be what I just wrote.
So yeah, just get rid of the radical symbol.
Oh, okay. Gotcha.
Yeah.
Is it all right if I leave a little early?
Yeah, I was just going to close with number 43.
Okay.
Okay, so 43, it's kind of like not like the others, because in the others, there was something that was pretty clearly inside something else that kind of got us going. And, you know, in this case, it might be better to start with the outside function. So the G here, not that clear, but what if we had F be x minus 1 over x plus 1, then what would be a g that you could put into that would create h? You got it. All right, great effort, everyone. That'll get it done. It seemed like everyone was getting into the rhythm, which was awesome to see. And I know you kind of, you know, had some synergy going with each other, seeing what the others were doing. So have a great night.
Thank you, you too.
Have a good night.
Thank you, you too.